The functionality of Marwell VanGogh Active Utility. The complete list of supported SSD drive you can find in a reference book. Reference book files are presented in your personal update boxes and you can download them at any time. These files contain information about supported SSD drive, information about their capacity, about their vendor, model and interface. Also in these reference book files you can find high resolution pictures of supported SSD and also find pictures of PCB. In this video we will speak about SSD drive based on Marwell VanGogh controller. Exist several modifications of Marwell 88SS9174 controller, and the most popular are BLD2 and BKK2 modifications. These two modifications have different microcode, and that's why our developers add in PC-3000 Flash two different utilities for several SSD drive produced by Crucial and Micron, and also for Intel SSD drive 510 series. Today we will speak about VanGogh utility functionality, and we also try to recover data from security locked SSD drive based on this modification of controller. And the first thing that we should do is make power on. Click on Universal Utility and select our utility. Here we can see that Active Utility provides basic information about connected drive. We can see the password information of this drive, its model, serial number and capacity. It's a 64 GB model, but the main interesting and important information are presented in log. Here we can see that our SSD drive is security locked. It means that someone set special password on this drive and block access to user data. So first thing that we should do is check, does our SSD drive provide information about user data or not. And let's try to reach user data using Tools option, Sector Edit. And let's try to check LBA number 0, it's master boot record. And we see that our drive returned an error because this drive is locked. And for unlocking we should use our utility for Marwell VanGogh drives. Let's switch the power, click on our utility, select it, and select our Crucial M4 series drive. This drive is connected to PC-3000 Express to channel number 0, and we can work with this drive through the PC-3000 Flash. Click Start. And right here we can see that our SSD drive is successfully reached the tech mode. Tech key has been initialized successfully, and also in log we can see some basic information about our drive. We can see its capacity 64 GB, we can see the count of channels and the count of logical chips, which combined in pairs into 8 channels. For now, as I told before, our SSD drive situated in tech mode. It means that our utility sends special tech command on our SSD drive, and for now we are able to make some basic operation with microcode of our drive, which situated in controller or probably in ROM chip on PCB, and this mode could be very useful in case if main microcode which situated in memory chips is damaged or corrupted. In case, for example, if memory chip contain too much different bit errors, so probably they have some bad areas and main microcode is corrupted. So using the tech command we are able to reach the data, the user data, and try to recover it. Also, tech command and tech mode provide several basic functions, and we will speak about these options and functions a little bit later. And for now, let's return back to our SSD drive, which is security locked, and in this utility we need to try get access to user data once again, choose the tools, sector edit, and check our LBA number 0. And we see that drive is still locked even if we use tech mode. For now the main microcode which is situated in memory chip is not working because we activate tech mode, and unfortunately this tech mode does not allow us to reach the data before we will not find information about the password which was set on this drive. Let's switch the power once again, reinitialize our drive, then click on Tests, Service Information, Security Subsystem and View Password Information. And here we can see that user set a simple password, it's 111, and for now we can use this password for getting access to user data. Click on Tools, SSD, then select SSD Security Subsystem and open SSD. Right here in this window we must set our user password in hex editor, so it should be 31, 31 and 31, and press OK. And now our SSD drive has been opened successfully, but we didn't remove the password. Anyway, for now, even if the password is still on this SSD, our drive is opened and we can try to reach data area without any problems. Try to use Tools, Sector Edit, it's already open, and let's check the same LBA. And we see that LBA number 0, which contains master boot record, is fully workable and we can reach the data inside this LBA. Right now we can use the saved data on this SSD drive. We can try to recover it, create a new task, but before we will do it we can also try to change the password or probably erase it. So we should select on SSD, Tools, SSD, SSD Security Subsystem and Clear Password. Or if you want we can set our own password. We can use any hex data here and set our own password for further encryption and security locking of our drive. But let's leave the default password here. We will not remove it because as I told before, the data is accessible, and let's try to check it. Use our PC-3000 flash kernel mode, create a new task, select our SSD drive connected to PC-3000 flash utility through the bus of PC-3000 flash, and click on Next, create a new task. And here we can see that our drive contains two main partitions. The first partition is bootable partition. It's created for Windows 7. It contains some folders, some structures, but the main data is situated in second partition, which have NTFS file system, and I think that the result is pretty good. We can reach all data here, save all folders and provide our customer full recovery. For now we successfully recover data through the tech command. Exists another way of data recovery. It's called data recovery through the translator tables building. This way provides better speed of copying and data access. With the tech command we are able to reach data only in PIO speed mode, and for some users it could be not enough. Translator tables mode provide us higher speed of UDMA 66 for PC-3000 UDMA and UDMA 100 for PC-3000 Express. So the data transfer will be faster and data recovery will be faster too. Sometimes This way of data recovery could provide better results than recovery through the TEC command. Right now we can try to build a translator using translator tables model and use the second way of data recovery. So click on Tests, Service Information, Translator, and build a translator. In this window we could select two options. We can start the search translator tables on our SSD drive, on our connected SSD drive, and also we can try to upload previously saved translator tables model from SSD profile folder. But we do the scanning at first time and we didn't save it before, that's why we should select the first option and press OK. Drive required some time because we have 64 GB capacity, and utility should scan the whole drive and find these translator table structures. After that, translator will built by our utility, and this translator will be uploaded into SSD RAM, and we will restore the functionality of SSD drive in our utility. But at the same time, this translator will not be written on our SSD. It would be written only in RAM. So after we will switch the power, our RAM chip will be erased and we will lose all information inside this RAM. That's why for further recovery and for further tests we need to save this model on our PC, and in case if we will need this translator once again, everything that we should do just upload these files from our hard drive. And right now we see that our scanning has been completed successfully, and our utility find several versions of translator tables. We can see that exist two types of translator tables. It's version A and version B. Let's try to use the latest version B, and also we can at this step save our translator into profile. Let's do it. Choose our profile and save it. At this step, after saving the translator on our PC, utility will upload these translator tables into controller, into controller RAM, and we will try to build a virtual translator, which will be used for further recovery through translator tables. This building is also required some time, so we should be patient and wait for several minutes. And now test is completed, translator has been built successfully, and right now, before we'll start recovery through translator tables, through translator, let's switch our way of reading between TEC command and translator tables. Click on Tests, Utility Status, and in this main window we see some information about drive. Also we see information about non-chips, and we see reading parameters. Available two main reading parameters for logical reading and physical reading. Logical reading allowed us to read data with all preparations and through the TEC command or translator. With this way of data recovery we will get the most complete image of connected SSD drive. Physical reading at the same time allowed us to read the memory chip without desoldering. With direct reading we will read only the raw data without any preparation, and our dump would be read without interleave elimination and without page transformation, without XOR elimination. Probably some user will try to build image manually in case if logical reading is not available, and make some operation with these dumps. Also we can read the dumps with removing all transformations, and this way provide better result than direct reading, because all preparation on our dumps will be already performed, and we shouldn't do a lot of different actions like rec sort, like interleaf elimination and other things. And right now, by default, logical reading is set by text command, but after translator building we are able to choose between using text command and using L2P table. Let's select using L2P table and press OK. Now let's switch back into our task, make a right click on the top result and press refresh. And now let's open our drive, our partition, and we see that we still have the perfect result of recovery. There is no red folders with red dot. All folders are opened correctly, contain a lot of different files, and our recovery is almost complete. We can save the root folder with all files, or probably we can make full copying of our SSD drive to other image, or we can also try to make copying data to another drive connected to your PC, or export the file of our image. And for now we can save the whole folders from the root folder. So let's return back to our utility and speak about other options available in this utility. Let's click on tests and speak about presented functions. About utility status we already speak before. This window provides information about drive, about NAND chips, and also it allowed us to choose the way of logical reading and physical reading. So we can choose and change these values, read dumps directly or with removing all transformation, and also we can read the whole folders and get access to data using text command or translator tables. Also, after we will build our image using text command like we do at the first step when we launch the utility, we also should try to use translator tables image building, because in most cases this way of logical reading provide better recovery results than text command. The next option is service information. It also include information about password, so we can check which password set on this drive. It contains information about translator. We can build a translator using the scanning of our drive or using the already saved translator tables models, and it also contains options of ID editor, and in this value we can change the model name and serial number structure. We can set any parameters here and save them. Factory reset allowed us to reset all settings to default at this drive, erased all information on this drive, all service structures, and restore factory functionality. We recommend to use this factory reset only in case if all data, all required data is already saved from our SSD drive, and we just need to restore SSD functionality. Probably the main microcode is corrupted. We can reach the data only through the text command and translator tables, but through the normal mode we can't do it. After we will make data recovery, just click factory reset and our drive will be fully formatted, and the customer will be able to use this drive in his laptop, in his PC, and this drive will be fully workable. The next option is user data. It allowed us to save the raw data from dumps and save dump with removing all transformation with the data. Sometimes if logical reading is not available in during the recovery, customer can try to save the dumps and work with them through the PC-3000 kernel mode or through the other software. And finally we see the option drive test. It contains two options: flash chip checking, which allowed us to read chip ID and check them. Right here we can see that all chip ID is reading successful, there is no problem, but sometimes when SSD is warming up, one of chip ID could be missed, or probably it will be colored in red, and it would be a sign that current SSD drive contains some hardware problem, and before we will start to walk through the active utility we need to try repair this drive or make some mechanical operation with PCB. Probably warm the whole PCB or cool it down and restore the soldering between PCB and memory chip. And of course the final test is utility reinitialization, which allowed us to make a soft restart of our utility, resend tech command on our drive and make some kind of soft reset for our SSD drive.